We're going to look at finding equations for tangent and normal lines to curves. So we've got a problem example here. Find equations of the tangent and normal lines to this curve. So you may or may not know what this word normal lines means here, but let's go ahead and start with the part that we do know about. We've been working on this for a while. We know how to find the equation of a tangent line to a curve. That should make you think about a derivative, right? So that we know that the slope of a tangent line is the derivative of the function at that particular point. Okay, and so we have a couple of ways to find derivatives. We know a limit definition of the derivative, and we used that for a while. But we've been working on some shortcut rules, and the whole point of those shortcut rules is so that we don't have to go through that limit definition every time. So this is a function that you know how to find the derivative of using some shortcut rules. So let's do it that way. All right, so our derivative, dy dx. So the derivative of the sine function is cosine function. That gives us the slope of the tangent line at any point, x. We want the slope of the tangent line at a specific point, x equals pi over 3. So at x equals pi over 3, our tangent, I labeled that m tangent for slope of tangent line, will be this derivative function evaluated at pi over 3. All right, and so we remember our trig values, right? So cosine of pi over 3 is 1/2. Okay, so when we write the equation of a line, we need a slope and a point. So here's our slope. The other thing that we need is a point on the line. I've got an x-coordinate of a point here, but I need a y-coordinate of the point. So that's what the original function is going to give us, input, output values. So for the y-coordinate of our point on that line, the x-coordinate was given, that's pi over 3, and the y-coordinate will just be from our original function, sine of pi over 3. And I'm sure you remember, that's square root of 3 over 2. Okay, so we've got a point, pi over 3, comma, square root of 3 over 2. And so we can write the equation of that tangent line to that curve with this slope and through this point. So I'm going to use the point slope form of the equation of the line, y minus y1 equals m times the quantity x minus x1. And you could leave your answer like that. A lot of times in the online homework or in the answers in the back of the textbook, they'll solve those equations for y, or they'll ask you to solve the equation for y. So at the very least, you might want to add that term to both sides of the equation. Okay, so the other part of this problem asks us to find the equation of a normal line to the curve. So you may or may not have heard that word used before, but that's also part of what's new in this section. So normal means perpendicular. All right, so when I try to find the equation of the line normal to the curve at that point, I'm actually going to use the work that I have over here already when I found the equation of the tangent line to the curve at that point. And so one thing that you want to remember from algebra is if you think about lines that are perpendicular to each other and how they're related to each other, the slopes of those lines are opposite reciprocals of each other. The slopes of two perpendicular lines are opposite reciprocals of each other. So I actually don't have to do too much more work here to write the equation of this perpendicular line to our curve because I have a slope of a tangent to the curve. So the slope of the perpendicular line, I'm going to write perp here for slope of perpendicular line, or you could write norm for normal, is just going to be the opposite reciprocal of that slope. So I'm going to have a slope of -2. The point, we're still interested in the same point. The x-coordinate is pi over 3, and we found our y-coordinate over there. So we're going to have a point pi over 3, comma, square root 3 over 2. So the same point, but this line that we're going to have will be perpendicular to the curve. So all I really need to do is understand that relationship. The slope of perpendicular lines are opposite reciprocals of each other. And then I can just write the equation for this line. So I'm going to write that again here. Same formula. I guess we'll start with the point slope form. So we'll have y minus y1 equals m times x minus x1. Or if we solve that for y equals negative 2 times the quantity x minus pi over 3. And then I'll add the square root of 3 over 2 term to both sides. So I'll have that at the end. So there's our perpendicular line. All right, let's look at a graph so that we can visualize what that looks like. All right, so we see here a graph of a sine function. And so I don't have any points labeled on there, but we can think a little bit about where that point would be. Pi over 3 is just a little bit bigger than 1. Pi is a little bit bigger than 3. So pi over 3 is a little bit bigger than 1. So we should have some tangent lines and perpendicular lines to the graph, right about where my cursor is at here on this curve. And so I've actually already typed in the answers that we got here. So we'll first look at the tangent line. So at that point, right there, we see what looks like a tangent line. This blue line on here, the first line we're looking at here is the tangent line. That's the first one we got. And then the second one should be perpendicular to that. So when I draw that graph, it should be through that same point, but perpendicular to that point. So you can see right there that it looks perpendicular. If you're graphing this on some graphing utility, a graphing calculator or Desmos or whatever graphing utility you might use, and if the graphs don't look perpendicular to each other, one thing that you might pay attention to is the graph settings on this one. There is an option about zooming square so that you can make sure that you zoom square if you are looking at the zoom settings. So I set up that window so everything's square so that 1 across is the same as 1 up and down. But often the settings are not set at the default like that. So if they're not looking perpendicular, you'd want to look for a zoom square setting. All right, so we'll look at some more examples in the next video.